Welcome to the SDG Warriors podcast. Today, we'll be in conversation with Miss Rosa Vásquez Espinoza. She is a National Geographic explorer, a chemical biologist, and a conservationist. Of Peruvian Andean descent, Miss Rosa grew up learning about traditional medicine from her grandmother in the plant-based pharmacy she created in the family's backyard. Today, Ms. Rosa travels to some of the most extreme natural environments of the Amazon rainforest, searching for unique microorganisms that could make our lives better. During her PhD, Ms. Rosa created MicroAmazon, a multidisciplinary project that explores the fascinating microscopic universe of one of the world's largest thermal rivers, the boiling river of the Peruvian Amazon. In addition to documenting new extreme microbes to expand our knowledge of Amazonian biodiversity and evolution and strengthen conservation policies, MicroAmazon aims to identify new molecules that could potentially be used in medicine, agriculture, reforestation, and cosmetics, as well as new biocatalysts for use in sustainable green chemistry. Ms. Rosa is a compelling storyteller and has participated in international campaigns with National Geographic and Disney on the recycling of common plastics in collaboration with PepsiCo and sustainability and natural products in the beauty industry in collaboration with Garnier. Ms. Rosa is the recipient of the 2020 American Chemical Society CAS Leadership Award, which recognizes outstanding PhD students and postdoctorate fellows that demonstrate promise as leaders in their fields. We are so honored to have you today on our show, Ms. Rosa. How are you doing?
Thank you so much for having me. I'm doing really good and I'm just super excited to talk to you.
Well, the feeling is totally mutual. To help our listeners visualize the experience, can you tell us where are you located, what is the weather like outside, and what can you see from your window right now?
So I'm currently in Michigan, so I'm in the north of the US, actually very close to Canada. So we typically tend to have a cooler weather, unlike Peru, where I grew up, where we typically have a really warm, fuzzy weather. But right now it's starting to get a little bit warmer. I'm at my house and I live very close to one of the forests that we have here. So I have a view of just trees, which is very lovely in the mornings.
Well, I can totally visualize the experience that you're having right now. How did Miss Rosa's childhood and school days look like?
So I grew up in Peru. My family is originally from a very small town high in the Andes, so a little bit more in the northern part of Peru. And they moved a few years before I was born. So I was born into the capital, but very closely linked to my family's history. So my childhood was basically a mix of discovering the capital city, more of like this quote unquote modern lifestyle, versus also having growing up with my grandmother and my mom. My grandmother always had brought in all the stories from their Andean town, and she worked. We have a small backyard in my house, and she developed like a small pharmacy in our backyard. So I was very always connected to nature, whether it was just at home or I got a chance to travel a lot with my mom during her job when I was little, and I got to visit different parts of rural Peru. And I was just a very curious kid. I grew up with my cousins as well, so always just playing, asking questions. And well, nowadays, I've been in the US almost 10 years now. I came to start undergrad studies and then work for a while, and then that transition into PhD, which is the last few months right now. So my typically day actually looks a little bit different each day, which is what keeps me really excited. So I most of the time I'm working in lab right now to finish up my PhD thesis work. But I get really cool opportunities like talking to you right now, or getting normally in non-COVID times, getting to organize some other opportunities with National Geographic. I just had a really nice collaboration come out between NatGeo, Pepsi, and Disney about recycling for South America. And well, actually next week with the educator I'm collaborating in Idaho through NatGeo Education, we are going to be doing a small exploration field trip with our classroom, but it's a surprise. We haven't told anybody yet. The kids don't know I'm coming, but now that we managed to get vaccinated, we will be able to make it happen. So it always varies a little.
Well, I'm so excited for the classrooms getting to meet you and collaborate with you. A new challenge each day following with your amazing passion. We heard about your story on National Geographic on plastic pollution. Can you please tell us more about it?
Yeah, so my work with NatGeo started about 2 years and a half ago, but I wouldn't do like officially, but I want to say that little steps in my life have been building me up to that moment, which is whenever I was 15, I did a trip with my high school at the time to the Amazon rainforest. I had already been to the jungle before, but not for an extended period of time without my family, and doing this more of like a research educational experiences. And that really just shifted my mind in terms of how I approach what I wanted to do afterwards, although it was not clear for a very long time. But when I started my PhD, I knew that eventually I wanted to do work with the Peruvian Amazon, and that it needed to involve nature, it needed to involve microbes, because I knew they were really cool and there were a lot of applications for that. And so the opportunity didn't really come until mid my PhD, where NatGeo opened up grants, and the collaboration that we were developing with the team at the Boiling River, led by Andres Russo, came together. And so I applied, and basically we were able to do our first collection trip right before COVID started. A few months before that, we went down a huge team. From my team, we were about 6-7 people, but we were part of a larger team of collaborative groups just coming together from literally over, I think, at least 11 countries, 41 people, including scientists, artists, etc. And so my work with National Geographic right now, it involves research that they are helping fund, that I'm currently completing in lab right now, which is involving the Boiling River Extremophiles to understand what are we having at this microscopic level in this very special part of the Peruvian Amazon. But I'm also doing a lot of work in communication, science communication, especially to younger kids, which I absolutely adore talking to, because you guys are the future. That's 100% true. So I'm doing a lot of collaboration through National Geographic Education and speaking with educators as well. And yeah, so that's a little mix of what I do.
Well, that's so inspiring to hear, a collaboration between the different scientists and they communicating their work to students like us around the world, how you explore the Amazon forest. It's very inspiring to hear. So if in case you had to describe your day to an 11-year-old, how would you do that?
Well, I like waking up, and then starting my day slow. I think I end up doing so much throughout the day, and a lot of that requires me to be able to think through complex problems in a short amount of time. So it requires a lot of brain power, I feel like, and creativity. So I like to start my days very slow, no rush, just give myself time, have a little routine. I think everybody needs that. I just have a slow, healthy breakfast that just makes me feel like full and happy and healthy inside. To me, that's very important. I like to slow down with music or meditation, just anything that gives me a safe space, so then I can breathe into the day. And then my typical day right now looks me going to the university, getting on my lab coat, getting my goggles, and then starting to do experiments. And they all really change per day depending on what I'm doing. So sometimes I'm working with chemicals in what we call the hood, a safe space, so in case because we're working with some dangerous materials sometimes. Another day that means growing the bacteria, and we have these giant tanks that we have to bubble in some oxygen, and we have like to put lights around them, and we're literally seeing Boiling River Extremophiles growing there in lab. Another day it's looking at chemical structures and trying to understand how things look without being able to touch them. So it's a varied day during the lab. I typically do have meetings as well, whether it's with the university or with NatGeo. Right now, of course, all of those are virtual. I like to spend time with people I like throughout the day too. So if it means taking a little break to go get coffee with a friend or something like that. And my family, it's all in Peru, so I always make sure that I stay connected with them, whether it's calling them for a little bit or texting. And if usually, unless my schedule is like extra packed or crazy, then I like to end up the day by doing something completely unrelated to science. I'm a very artistic person as well. So that really changes depending on the mood. Sometimes I like to do dancing, sometimes I like to paint a little, sometimes I just like to read. Or right now I started actually a little interview series with different people from the Amazon rainforest, whether they're community members or artists or scientists. So that for me, I call it artistic like outlet, just because it's so, it's kind of what you're doing right now. So yeah, I like to keep it mixed. It just keeps me motivated and really inspired. I like to shift things around a little.
Wow, an artistic scientist. So what advice would you give to students who want to become just like you?
I would say everybody is absolutely unique, and everybody has this unique thing that they're going to bring to the world, and maybe they just don't know it yet. I would say a few things. One, don't go by convention just because things are an exact way right now and careers look an exact way. That doesn't mean you need to find one within those that will meet your needs and that will help you develop as much as, professionally and personally as well. I feel like especially, our generations, your generations have had more of a freedom to be able to build new careers. So if we think about careers that are available right now versus 10 years ago, nobody would have thought, that people could literally build a career off of the internet. And now it's a total reality. So I would say, don't limit yourself by what's out there, but put together all the things that you like, even though it makes no sense to combine them. Because when I first started, I had a lot of people tell me it made no sense that I like so much art when I wanted to dedicate my life to science, like scientific research. But I just like to keep it together because I said at some point it will make sense. And now it is with all the things that I'm doing with NatGeo. And I feel it gives me more of a unique perspective to an approach towards the things that I'm doing. So I would say keep those in mind. Even though if it, keep exploring your curiosity as much as you can. And then two, keep doing things while they're fun. Of course, things are gonna get hard at some point in anybody's career and stuff, but I feel as long as we are following that curiosity, it is always gonna lead us to the next interesting question, whatever that is. And I think that's where we get to expand ourselves best and give our best gift to the world. That's, I think, what we all want to do. So I would say that just don't limit your beliefs, follow your curiosity, and have fun. That's the most important.
Absolutely. Using your skills, using your passion to carve your future. That's so inspiring, ma'am. So we would love to know more about you. As a researcher, what tools did you use to study the Amazon forest? And from where do you exactly begin your research?
So the research we're doing, we have a few main goals. The very first one was to answer a question that what is the microscopic life like in the Amazon rainforest? When I first started to think about all of these questions a long time ago, I was shocked by the fact of how little information we had. So we know about the beautiful trees and flowers that we have. There are at least, the majority. We know a lot about the animals. And whenever we talk about biodiversity, usually the talk that everybody focuses around, it's these things that we can see with our own eyes. So macroscopic life, things that we don't need a microscope for. And that's beautiful. Of course, that's the beauty of nature. However, something that is just left behind a lot, almost as a silent hero, in my opinion, are microbes. Microbes, all these teeny tiny forms that unless you have a microscope, you most likely won't be able to see them. They're the base, the foundation for all these other beautiful large forms of life that we see. They are responsible for maintaining recycling systems on Earth, for being able to give us nutrients, even within our own bodies. We are made up basically of microbes. There's more microbes on Earth than there's more stars in the galaxy. So that was the first question. What do we have at this microscopic level in the Amazon rainforest, specifically in the Boiling River? Because the Boiling River is such a unique thermal river that there are other thermal rivers in the world. But one, this is one of the largest, and two, is located within one of the hottest spots on Earth in terms of its biodiversity, the Amazon rainforest. So that just makes it completely unique. And by understanding what's in there in the microscopic level, perhaps that can give us a better understanding on how to eventually protect it. Can we understand the different patterns? Perhaps when there's more of these microbes, the plants are able to sustain heat better. I don't know. Or perhaps whenever we have less of these other microbes, then the soil gets more fertile. There's so many more questions that could be explored by first answering that question, what do we have? So that's the first goal that we're currently working on, hopefully towards publishing at the end of the year. And what that looks like, it's the first aspect, which is what we did in our collection trip. We physically go to the jungle and we start collecting samples. We bring different sterile tubes from the lab, different tools so that we can collect a little bit of sediments, or so that we can collect what could look like green algae floating on the water, but that is actually a mix of different microorganisms. And also something that we call lichens, which is if you go in any park, usually, and if you focus on the trees or on the rocks, many times you're gonna see a patch. Perhaps most times it looks circular, and it may have different colors. It's almost as little prints all around. If you notice that, that's actually a mix of fungus with some sort of algae, and they have this ability throughout many years on Earth to be able to sustain harsh conditions of life. So we also scrape some of those, and then we take those to the lab. And then in the lab, then we do a variety of different things. On one aspect, we focus on the genetic information, so the DNA of all of these organisms that we have to, undergo a specific process so that we can obtain the DNA, and then we can actually read the code of life for these organisms, because that allows us, one, to know exactly what species they are, so we can start doing this documentation, this mapping that has never been done of microbes in the boiling river of the Peruvian Amazon. And then from there, we can take that even farther and try to, and from this genetic code of life, understand what their function is in the ecology of the location. Because we have this collaborative project where it's not just us, but we have a geology team, a botany team, and all these different experts that have been studying the boiling river from different perspectives, then we can connect that information with what we have and start to build patterns, exactly as I was talking about. And then the next step, once that is complete, it's going a little bit farther and trying to increase the value of the biodiversity in the area with the goal of strengthening conservation efforts. So that looks like, for example, microbes have this capacity to be able to produce medicine. They literally are like mini chemists, mini factories within their own cells that can produce these molecules that can serve as cancer-fighting drugs, as life-saving antibiotics, and also as perhaps tools for agriculture or biotechnology. And so the next thing that we're going to be doing is looking at, are these extremophiles in the boiling river capable of that? And most likely they are, and perhaps because there are these extreme conditions, perhaps they're doing interesting chemistry that we have not seen before, and that could help us answer even more questions. And with that, we can strengthen the value of the area for people to conserve it more.
Well, using microbes to make medicines, that's something really interesting, and that totally caught my attention. And also you talked about the boiling river. So what exactly is the tale behind the boiling river, and what makes it so very special?
So there is a TED Talk that I absolutely recommend everybody to watch, and it's associated with a book by Andres Russo, who is a dear friend and my mentor in NatGeo. He made the boiling river known to the world back already a few years ago, but it's one of the largest thermal rivers on Earth. It has no volcanic origin because the nearest volcano is over 400 miles away. So most of the times, whenever we see a hot spring, it is going to be associated to some sort of volcano, and that's how it warms up its water. That's not the case here. So there's multiple theories. That's actually part of his work. There's multiple theories as to why it's heating up, why it's boiling up. But one of them, it's that the origin actually of the water source starts from the Andes and then goes so deep into Earth, into the core of the Earth, that it gets boiled up and warm up there, and then it comes out shooting off with so much strength. And then on Earth we have like little cracks sometimes, and then through one of those cracks, that's how the water is coming at such a speed, and then the boiling river is created. Because when you get there, not only is the water extremely hot, it can get 99.1 Celsius or more, which is literally boiling water, as if you're boiling a pot here. You can boil eggs, right? Cook chicken, for example. But it's also the water is flowing with a lot of strength. So you have a large volume of water that is flowing with a lot of strength. You have different points throughout the river where the hot water is coming in and constantly feeding the temperature, maintaining it hot. And also one of the earliest records that we have on the boiling river dates back to the 1800s. So it's been there for a very, very long time. So all of these things combined, plus the fact that life around the boiling river doesn't mind that it's so hot in there and that the vapor itself is extremely hot. The life around it just keeps growing. It just keeps flourishing. And then also the microbes throughout the river as well. So all of those things combined make the boiling river such a unique, beautiful place to really understand so many aspects of nature, but also including the evolution of life. Understanding how life came to be in the Amazon rainforest, for example.
This question just came into my mind. How do you survive and how do you work in such extreme conditions?
So the boiling river flows hot for nearly, I want to say 4 miles, 6 kilometers, give or take. But it eventually does cool down to the point that the water becomes actually cold to the touch, as it becomes also smaller. So there are some areas that are really hot, but then it starts to warm up. You can, it starts to be just warm enough, like comfortable enough for you to even walk in until eventually it's cold. Now, something interesting in the boiling river is that even in the hottest spots, there is large pieces of rock that you can actually walk on. The rock itself gets warm from the temperature of the water as well as the steam. So the steam that is coming off the water constantly is really hot. You feel like you're in a sauna that it has been turned up to the highest option. So you have large pieces of rock that allow you to walk, safely without being in danger of falling in. Now, that being said, there are some areas that are very difficult to access because those rocks become smaller. And as they grow smaller, sometimes they're not placed necessarily fixed. So you have to be extremely mindful of every single little step that you take. There was a really cool experience that we had in our collection over there, which is we were exploring different areas of the river, and then we arrived to a section that they told me to get to the other side, you needed to climb a little wall. Now, keep in mind, you have 80 Celsius degrees temperature below you, so it's still very, very hot, right? You do not want to fall in there. But then because getting to the other side was so difficult, very few people had done it. And the first thing that I thought was, well, then that means that it has virtually little contamination to none. So perhaps it's even more interesting to collect samples from there. They are almost, they've less exposure to human intervention. So I was like, well, I need to get to the other side. And then they explained how to do it. And you needed to climb in a way that you have to put your arms like this and your arms as well, and your legs like that as well. So you look like Spider-Man at some point whenever you're doing this climb. They told me no girl had ever done it in the expedition. So I said, well, I have a little rock climbing experience. Let's try. Is it safe? Can you guys guide me? And so I decided to go ahead and try it. Of course, I didn't tell my mom at that time because she would have killed me. But I did this as safely as possible. There were two guys that already had done it multiple times. So one was on the other side, the other one the other. They were guiding me as I got through it. Those aspects perhaps are a little bit more dangerous, but always within a safe environment, trying to, not put anybody at risk. That's not the point. The point is just to push the limits a little.
Right. So what are the most mysterious facts that you found out about those microbes which are present in the Amazon forest and in the boiling river?
Starting to look at the microbes at this metabolic and genetic level, so just getting really close to understanding how they're even made up, how their systems inside are made up, is giving us a really interesting look at the ecology of the place. We are being able to start putting ideas and supporting theories that perhaps other teams had seen, but were not able to corroborate fully. But now with our work, we are getting closer to answering very interesting questions that perhaps have never been answered there before. So I cannot tell you much more than that, except the fact that it's been an amazing journey. And every time we get results, I get overly excited. It's, work that of course is difficult and we have to work hard at it every day. But no, we are identifying, I cannot say in detail, I'm sorry, but at least species that have never been identified in the area before, which is really exciting as well to see. So we're also trying to understand how those relate to how life evolved there. So I'll be able to tell you more at the end of the year, hopefully.
We would love to hear all your stories, Miss Rosa. We should totally connect after this podcast so that you could tell us more about your research. It sounds so very interesting. At the start of the podcast, you mentioned about your grandma and how she inspired you. We would love to hear more about your grandma's stories and about medicine. What is the most amazing link that you found between her stories and the work that you do or today's modern medicine?
It's a beautiful question. The last one you did, the link between the natural medicine, this ancestral knowledge almost, right, and the scientific research. I think that link has been the question that has drove me from the beginning, and that it still drives me today to understand that. And yeah, it really starts with my grandmother. So as I said, they moved to the capital before I was born, but my grandma was so used to being the person that everybody went to in their small community before whenever they were sick. So she would treat people with natural medicine, because back in the small town where they originated from, there was very little access to medicine, very little access to, conventional like Western doctors or even pharmacies. So they rely really on the nature that they had around them, right? So like, I use these plants for this purpose, or I combine these things for this other purpose, whether it's a stomach ache or you are feeling, you have a rash, etc. And I feel like, for many people, grandma plays this role of like, I know these little secrets that has been passed down the family, right? And that's always just a beautiful connection. So I had that with my grandma. And then in Lima, where I grew up, she literally made our garden into a small pharmacy. So whenever somebody was sick in my family, or even me growing up, I would go with her and she would tell me, well, this is how we're cutting this because we don't want to disrupt nature, but we need these leaves. So then we take these things and then we're going to be doing this mixture. And then this is how you apply it. And I was just extremely fascinated because at the time I was learning about science and chemistry and biology in school. And there was I didn't really see the link as to Peru, a country that has such a rich traditional medicine knowledge, and that not being shown into the scientific literature and the books that we were being taught in school. So I saw this connection, and I know your country has beautiful, history of traditional medicine as well. I actually got to work in China for a while in a traditional Chinese medicine hospital over there, which is really strengthened more what I'm telling you about. Like, countries like ours have this rich history. Why are we not meeting this scientific work that can make this knowledge even stronger and be able to be more permanent throughout time? So that just really fascinated me, and especially whenever I first heard about the concept that a lot of the medicines that we get from plants actually come from the microbes living in and around the plants. So, for example, Taxol, which is a very famous cancer drug, originally came from the Taxol plant, but it has been discovered as well that the microbes living in the leaves of the plant can actually produce this drug, this medicine as well. So to me, that was just fascinating. Then I said, well, we know all of these great things about plants, but at least before, in a lot of these cases, we need to cut down the plants so that we can get that medicine. So there's a little disconnection there, right? We want to protect nature, but how can we find a way that we don't have to destroy it so that we can get the benefit out of it? Can we protect it with it? And, if you think about microbes, you can barely see them, so you need a teeny tiny bit of it, and then in the lab you can make way more. So you stop cutting the trees, you stop disrupting nature, but you can still use this positive aspect of it, that nature is literally providing us with the medicines that we need. So that's what fascinated me. And then at that time I wanted to read more about, okay, well, if microbes are so cool like this, they're not always bad. Sometimes of course they are, and we know that, but in the case when they're actually good for us, what can we find about the Amazon rainforest? I said, the Amazon is such a rich, beautiful place. What do we know about it? And at that time, there was literally basically, nothing I could read in terms about the medicine coming from microbes. And that's what we're trying to change. Now, towards your last question, what am I finding in terms of these connections? I think that, well, first of all, my grandma's dream was always to become a doctor, but she didn't get the chance to get formal education because back in her time, when in the small town, girls were actually not allowed to go to school. But then she made sure that the next generations would in her family. So my mom and then me and etc. So she's always just encourages, educate yourself as much as you can, learn. And even though she technically didn't have this, for me, she's one of the smartest people I know. So I feel like the connections that we're making is that areas that are highly biodiverse can also contain some of the most interesting new tools that we could be discovering. But also, we should not just get, disregard areas that perhaps look more common and like, I don't know, let's say our backyard here, that we don't really have any exotic necessarily plant and just soil and then a few trees. Those can be equally powerful. And I think that's something I've learned from my grandma. Just, you don't always need to go to the most exotic thing to find the coolest discovery. And that's something I'm definitely finding in my work. It just really matters how you're looking at the problem and how hard you want to try to solve it.
Right, it's all about problem solving. I can totally connect with all the things that you're sharing right now. There's so much of indigenous knowledge that we need to revisit and say before it's lost in development. In India, we have Ayurveda, so I can connect with all that knowledge. So what is the role of extremophiles in our environment?
So I think that the most relevant actually example is COVID testing. So one of the tools that allows us to literally test for COVID-19 nowadays is a technique that is called PCR, polymerase chain reaction, which is basically a lab tool that was discovered and developed long time ago, but that uses an extremophile so that it can actually, the process, it can happen quick and not take days or weeks. And that process, that extremophile that was included in the technique, allow for us to be able to get a little amount of sample and be able to amplify and replicate the DNA from that so that we can actually do useful things like test for COVID-19, or perhaps if we want to test for parental origin, or if we want to even test things for, in the police, for example, when you're looking at investigating if somebody made a crime or not, or different other diseases besides COVID-19, etc. And that extremophile was actually originally discovered from the boiling rivers of the United States, Yellowstone, which is actually where I'm taking my classroom next week. So I have to keep you posted on that. But basically, a long time ago, there was a scientist that was working throughout Yellowstone and just went by those boiling waters and thought to himself, can anything survive there? Because we know that we as humans, we absolutely cannot, right? We will boil within minutes, within seconds. Same for an animal and a plant as well, right? If you put it in there, the leaf itself, it will cook. But then, so he asked himself, is anything able to live there? And he did found that some microorganisms, some microbes have had the ability to evolve their own DNA and everything that makes them up so that they could adapt to these conditions and not just barely adapt, but instead flourish. And that's one of the theories of the origin of life on Earth, actually, that we started, they call it the hot origin, where everything started as basically a hot explosion. And really, if you think about it, if the temperatures were so high, only extremophiles could have survived that. And then they started to populate Earth. And then as oxygen came into Earth, then things are starting to evolve. And then eventually the life that, you and I and that we see around came to be. But extremophiles still play this important role and stay around. So thanks to that scientist asking that question and finding that one extremophile that had the proteins that its own organism is making be able to sustain very hot temperatures, made it possible for us to have this technique called PCR that now literally allows us to test for COVID-19. So I would say that's one of the best examples of the role that extremophiles play in our life nowadays. But I also think that they're closely linked as to how even life came to be on Earth. And there's still so much we don't know because of the fact that they grow in these extreme conditions. For a very long time, it was very difficult for us to study it. Technology was just not there for us to explore them as much as we could. But now it is. And technology is getting better literally by the minute. So whenever, I came with the possibility of studying the boiling river, then I said, I think we are at the right stage now. I think we can do this, right? So the goal would be to also inspire other people to look at their own country, their own nature, what places have not been, explored yet, and this microscopic level, what areas need to be more protected, where can we do better, and how can we use science to do that?
Well, people like you always inspire me for being more curious and asking all those questions and going ahead and deeply researching into all those little questions that we have, because eventually it's totally going to make sense and perhaps it can perhaps even be a discovery. Thank you so much for sharing this. Your passion is very infectious. Well, Miss Rosa, have you discovered a new extremophile or its application to solve a real world problem except COVID-19 that you mentioned right now?
So I cannot disclose at this moment exactly the new extremophiles that we have, identified or are looking at, or the potential applications, but I can tell you some of the new future avenues that I think the kind of work that we do it can go, and the potential applications, and not just us, but other people looking at extremophiles around. So one application, actually, I think nowadays, so many of the processes that perhaps we don't see, how pipes are being cleaned in a facility that makes yogurt that we eventually eat, and how some materials that are being used for agriculture are being made, things that we don't think about because we only see the end product that we consume. A lot of those processes right now are already being benefited by bacteria, and some of them by extremophiles. So just to give you an example, there's a company in the United States that makes yogurt that we literally eat, that I actually have in my fridge here, that they use a kind of extremophile to clean their pipes. Because extremophiles, again, they can sustain these hot temperatures, then they're able to clean and maintain the safety of their plant, much lower costs, and really, like, almost in a way faster by being able to use these extremophiles, because then they can use acidic components and be able to clean everything better. So that's just an example of how extremophiles are in our lives. We just still necessarily don't know it yet. I think another one of the applications that this type of work can eventually lead to, one is microplastics. So we know the problem, plastics are literally everywhere, that we are very aware of that. I literally just did this collaboration where we're trying to teach people how to better recycle because of that. However, right, the field now in that aspect is going to look at the micro and even nanoplastics, where these are infiltrating rivers, even our own bodies. I actually have a colleague that is looking at microplastics that are being found inside sharks and how much that's literally changing them from within out. And sometimes they even have found nanoplastics in the human heart. So I think because we cannot see these micro nanoplastics, I actually think that extremophiles and bacteria in general could be our allies there. Because bacteria have this amazing ability to adapt so quickly to their environment around them, and by that they're able to sometimes consume what they have around them so that they can keep growing. So the idea is, can we use bacteria or extremophiles to adapt to consume plastic so that they can help us break it down? And I know that there are some labs already in Europe starting to look at that, but I think that's one of the next applications for extremophiles. Another one, bioremediation. We have a lot of oil spill, unfortunately, happening all around the world, especially actually in the Amazon rainforest. People talk about, okay, yeah, what are the things that we can do? But realistically speaking, how can we fix that problem with minimal invasive approaches, right? Where we still protect the people around. And there's bacteria that has been shown that they have the capacity to be able to consume petroleum and oil and break it down. So literally cleaning the environment. So I think those are amazing applications that extremophiles have, that we're gonna be seeing more of in the next future, in the next few years.
Bioremediation for oil spills and how microbes are helping. So I have a question in mind, that how can we as a species, as human beings, what can we learn from these extremophiles?
I think one of the most beautiful, more philosophical things to learn that I like to think about is, one, bacteria do all of this very silently. For me, they have a very humble job, which is they literally maintain life, but we don't think about them, and sometimes we don't even acknowledge them, but they still do it. So again, a more philosophical approach, perhaps. I like to think of, I like to believe that we can do great work and be very humble about the great work that we do and be able to speak up for ourselves, but also just keeping humility alongside, I think can take us to really, be able to connect more with people and always being willing to learn more, because I feel like being humble allows one to keep asking questions and realize we don't know everything. We can always get better, and we should not be afraid to ask questions. So I think that's something that I like to take from microbes, and also the fact that they can adapt so quickly. And to me, that's one of the most important qualities that we also need to have as we explore our curiosities, as we explore challenges, as we try to answer questions. Nothing is going to go the exact same way that we want it to go, and it shouldn't. That's actually science. I think that's also art, and I think that's the beauty of the spark of life that we don't necessarily, fully comprehend just by science alone. So I think just being flexible, just like they are, and I think we now, as a whole human species, that are needing to adapt so quickly to climate change, which is, a real issue that is continuing to aggravate over time. I think we can now take the lessons of how bacteria is able to adapt and try to apply that for perhaps plants and help plants adapt better over, the climate change that we inevitably are going to have elevated temperatures. The same for animals. I feel like we can take microbes and give them a higher role so that it can actually help us conserve the beautiful life that we see with our own eyes.
Well, the best things come in small packages, like in microbes. I totally have a new respect for microbes now. Well, what are the threats to extremophiles, if there are any threats?
So I would say the biggest threat is the fact that there are some areas of the world, actually most of them, where we know so little about the microbes and the extremophiles living in there that we don't know what we're missing. Now, there is well-documented work that shows that, let's say, we talk about a rainforest that is virgin, nobody has touched it, versus rainforest that has undergone deforestation and logging and etc. The microbes that live in the first virgin one are so much rich. There's many more types of microbes than in the one that has undergone deforestation. So just as we lose the trees and the animals, we're also losing a lot of microbes. So how much information are we losing there? We don't know. And I think that's the scary part, that we actually do not know what is already being lost. So I think that's one of the threats, that they're not being brought into the conservation the talks about conservation. I think that big organizations around the world should start bringing microbes into, whenever they're talking about conservation, they should also consider those, that when we're looking at an area, we should not just document the plants and the animals, we should also document the microbes and see how that changes and how can we protect the ones that are beneficial for us. And I think that we're going to start to see in that shift. I'm starting to see more, at least scientific documents that are coming out where they are literally asking the same questions I'm talking to you, like I'm telling you right now. How can we bring those into the conversation? And I think within the next 10 years, we're going to have a clear answer to that.
Completely agree with you. There should be, in conservation, just like we conserve plants, we conserve animals, we should treat them equally. And over here, the place of equality comes into play. There's a lot of potential which is there to bring more discoveries into science by studying these microbes and how they adapt so quickly into such extreme conditions. So I had a question in mind. Can we artificially replicate the adaptive features of these extremophiles to other organisms?
That's a beautiful question. The answer is that's exactly what I think technology is allowing us to slowly be able to do. Be able to use, and that's part of the basic work that we're trying to do here, by being able to understand how they look at all levels, genetic, chemically, etc. Then we can try to pinpoint down and really focus on what sections of those give them that ability to grow in these hot temperatures, to adapt so quickly. And can we take that into an organism that doesn't, and can we make it? That's actually called chimeragenesis. It's a tool that allows us to mix something that you want from an organism to another so that you can give them these new tools. We're able to do that with other microbes, actually. We literally do that in the lab for other purposes. So I think that moving forward, as we understand extremophiles better, we eventually would be able to adapt that, because extremophiles have a little distinct makeup. But I think we will be able to do that. And I think that's one of the things that excites me the most, is how can we use them perhaps to help protect plants that are not able to withstand the elevated temperatures that we already have, that we're losing. Can we use these awesome, microbes that we can develop to help protect those plants? I think that's something that some groups are looking at, and I think we're going to have more cool research coming from there.
Well, totally, and we are so looking forward to all these technological advancements and what is in place for us in the future. From your adventures so far, what have been your biggest learnings?
That everybody has a really awesome story to tell. I think I'm so fascinated by the people I get to meet, whether it's going to the jungle and talking, with community members or people I meet across the way. I'm fascinated by doing work in nature, and I think reminding us that us as humans are part of nature. We are all integrated together, and I think always just making sure that you can always learn something from anyone. I think people sometimes forget that, and they don't fully listen. And I think that has led me to where I am today as well, being able to build more meaningful connections and being able to look at nature even through their eyes just makes my mind expand in a positive way, and being able to understand how different people approach their work and their passions. I think that has been one of the greatest learnings for me and treasures really from the work I do.
Stories from other people, being a lifelong learner and delving in deep into their perspectives. You inspire, ma'am. So we are going to wrap up this intense round of these questions with a rapid fire round. So are you ready, Miss Rosa?
Let's do it.
Okay, first question. In school, which was your favorite subject and why did you like it?
Art and geography at the time, actually. Art just because they let us paint as much as we wanted and I was doing a lot of projects with nature. And geography because it was the projects that allow us to actually physically go into the field, and that eventually led me to biology and chemistry. But yeah, I had a lot of fun with those at school.
Right, I love art as well. When Rosa is not in the forest or labs, what does she like to do?
I love to eat, so I love to try new foods and I love to actually watch movies as well, and I love to discover new places. Just go to a new place without necessarily a plan and just, seeing what you discover, even if it's, looking at beautiful houses or just like walking. I like to go with the flow.
Well, which is your favorite food, Miss Rosa?
Oh, okay. Right now I'm actually thinking what a soup that is called chilcano, which is a soup from Peru that you make with the remainings of any fish that you have, like what you don't usually eat of the fish. You put it together and boil it with some herbs. That.
Well, my mouth is watering right now. What are the best parts of your job?
Talking to people like you. Talking to younger explorers. That has been the most rewarding thing for me.
Well, the feeling is totally mutual. We as students love to learn from our elders because they have made the pathway for us. Well, what are the worst parts of your job?
That in science, a lot of things go wrong and we only hear about the good stuff. So when a lot of things go wrong at once in the experiments, you can get really frustrated. And we just don't hear enough about it. And I think we should, so that people understand that we are not always going to be winning, and that's completely okay.
Okay, who has been your biggest inspiration? I think we all know that. And what lines of inspiration would you like to pass along to all of us?
My grandmother and my mom, they've been my two biggest supporters. I would say my grandma always says a sentence in her native language, which is women of the brave heart. So I like to think of that as, women being able to lead without fear, being able to take charge of their own lives and their own roles and whatever they want to do without any misconception. And I would say my mom, one of the biggest things that honestly I always try to tell everybody is, we as whenever we grow up and we want to explore all of these things, a lot of the times one of the things I used to think about was, they're not going to take me seriously because I'm just a kid, or they're not going to take me seriously because I don't know what I'm talking about. I was, perhaps I was 15. I had no idea. But she always did say, nobody's going to close the door to a young person that comes with curiosity. Nobody. So she said, as long as you just go and present yourself and ask questions. So that helped me overcome that little fear. And I think that has just opened up so many doors to me.
Well, that's such a big takeaway for our audience today. The COVID-19 pandemic has had a devastating impact on the world. So I just wanted to know, how has the pandemic affected researchers like you? Except the bad, has it had any positive effects?
I think, a lot of us had to be outside of lab for an extended period of time. And then when we were able to go back, we were very limited, and perhaps in terms of timing. And perhaps that works for a lot of jobs, but unfortunately science, maybe a few things you can time them, but some other stuff you need to go with the experiment. And so that goes against the nature of our work. So that makes it a little bit difficult, but not impossible. I would say the positive thing is that it made everyone in the world, no matter where you live, what job you do, what age you are, realize that it's okay if you don't do much. Nobody's going to, freak out if one thing doesn't get completed. And I think that for us that are working at a high pace, often in lab, because we're dependent on the experiments, timing, and etc., I think it just reminded us that there's nothing will go wrong if we slow down. And I think as a whole community, we've learned that. And I think that's beautiful.
Absolutely. Slowing down. This pandemic has taught it how to slow down and take one thing one at a time.
Yes.
So coming to the last and the most important question of this podcast. As children, what can we do to make the world a better place?
I feel children have such an important impact on the communities that perhaps sometimes is not well highlighted. So as children, I don't think perhaps one as a child necessarily realizes you influence your parents, because what you are interested and curious about, you will be talking about, you will be reading about, and then inherently your parents are there and they're going to be learning with you. So wherever your curiosity leads you, it would also lead your parents. And I feel like if we keep in mind things that we love and that are making us happy and that, make it fun for us, I think that is a leading driver of what kids should be doing. But also just looking at the world around you, and whatever it is that you focus on, how can you make it better? Whether it is, in my case, I want to protect areas of the world that are getting destroyed. For me, that's my way of contributing to make things better. But perhaps somebody else can come and look and, I don't know, try to help elderly, with their grocery shopping, which is, such a perhaps many things people won't think about, but it makes such a huge impact. Or perhaps, helping others in need, or perhaps even cleaning the plastics that are left outside in your street. All of these things that are helping the world helping the world become better. And I feel like as children, we should, yes, focus on the fun, and also look whatever it is, how can it make it better? Because whatever you do, you'll have a ripple effect in your life, in your parents, in your community, and like that, literally in your country and in the whole nation. So I feel you guys all have a beautiful opportunity to explore as much as you can, and not be confined by what people tell you to do or tell you who to be, because you decide that. Just keeping in mind a higher sense of purpose. I think, to me, that makes things better even when things are not necessarily easy and perhaps are hard, because it keeps in mind that my goal is to help nature in this way. So even if perhaps, I had a bad day or I had a bad criticism or something, I am able to take that away and not take it personally, because you know what? My goal is not to necessarily make myself bigger or, have more spotlight on me. My goal is to highlight what I do, and I use my talents as a tool to do that. So then that helps me just stay focused and stay humble and stay positive and always, again, constantly learning. I think kids have that ability when they are young, and we should keep that and protect that as much as we can.
Well, you're being the change by asking questions and using curiosity. I'm feeling so empowered right now. Those little things of kindness, those little acts of kindness. Miss Rosa, you're a real world Lara Croft. Your curiosity, your passion towards extremophiles and fearlessness inspires. Thank you so much for talking to us today.
Thank you so much.